Hello, everyone. So in this video, we will be discussing functional groups. So functional groups basically, guys, are a special set of molecules or organic compounds, which actually have distinct characteristics and distinct properties because of the extra atoms which are on them other than the carbon and hydrogen. So for instance, we have seen long hydrocarbon chains, right? And we know, for instance, this one with all the single bonds, we call this alkane. Now, this is a simple hydrocarbon, simple organic molecule. But what if we start adding different atoms to them, like oxygen, or if we start adding nitrogen to them? So when we do this, what we make is what we call a functional group. So we will be identifying that if you add OH to a carbon chain, or if you add nitrogen to a carbon chain, then what do we call those molecules? Okay, and we will be responsible for identifying them and for also learning the introductory nomenclature for them as well. Okay, so to get started, guys, the very first functional group that we will be talking about are called alcohols. So guys, alcohol, again, it is an organic molecule, but it has something special on it. So for instance, if you have a long carbon chain, and on that carbon chain, if I add oxygen, and that oxygen is bonded to hydrogen, so when you add OH, which is also called hydroxyl. So OH is called hydroxyl, guys. So whenever OH is added to a carbon chain, we call this molecule alcohol now. Okay, so this part is what makes alcohol an alcohol. Okay, so usually when we are defining alcohols, what we try to show, instead of showing exact number of carbons, we can say, okay, we have a hydrocarbon chain, an alkyl group. We just call it R, and on the R we have OH. And this again is what identifies the alcohol. This R could be, 4-carbon chain, 2-carbon chain, or a cyclic chain. So any hydrocarbon chain which has OH attached on it. Okay. All right. Now, understand that oxygen always likes to make two bonds. So if you have a carbon and you attach oxygen to it, this oxygen already has one bond with the carbon. It needs one more, and that bond is made with the oxygen. It could be made with different elements, but when it's made with hydrogen, that's when you have alcohol. Okay, if you add a carbon here, then you got a different functional group. Okay, all right. So the next example we want to discuss is, let's actually discuss what happens when you have R, which is again alkyl group. So any number of carbons, it is attached to the oxygen, but instead of hydrogen, it is attached to another alkyl group. If it's the same, we can just call it R. If it's different, we can call it R prime, just to distinguish R from R prime. Okay, so what is this saying? This is saying if a carbon is bonded to oxygen, and if it's again bonded to a carbon, then we have a different functional group, and this functional group, guys, is called ether. Okay, so you should be able to tell how ether and alcohol are different from each other. Alcohol has oxygen bonded to a carbon and hydrogen, whereas in ether, the oxygen is bonded to carbon on both the sides. Okay, all right. So if I, just draw another molecule, for example, so let's say I draw a cyclic structure, and on that cyclic structure, I have oxygen, and then here I have another carbon chain. So you see this is one R group, and this is another R group. So that makes this molecule ether, because again, the carbons are connected with the help of one oxygen. Okay, and that's what the ether is. Okay, now we'll discuss the next functional group. This functional group, guys, is aldehyde. And when we discuss aldehyde, we will discuss the ketones together, okay? Because they look similar, but you have to be, I mean, they don't look similar, but they have the same carbon double bond oxygen, but they're very different in their properties, and we must make sure that we identify the difference between them, okay? So like I said, these molecules, they have a carbon double bond oxygen, okay? And carbon double bond oxygen by itself, we call this part, we call it carbonyl. So carbonyl is the term used for carbon double bond to oxygen, not single bonded to oxygen. So this CO or this CO is not carbonyl. Carbon double bond oxygen, that is carbonyl, okay? So what we have here is a carbonyl is present, okay? And here you have a hydrogen connection. So carbon can make 4 bonds. So this carbon has a bond with the carbon on the left-hand side, with hydrogen on the right-hand side, and 2 bonds with the oxygen, okay? So if I try to draw this molecule, you know, this is what it will look like, okay? So it is, this you see is a carbon, it is double bonded to oxygen, and you have a hydrogen. Okay, one thing to notice here is that whenever, if you want hydrogen on a carbonyl, then the carbonyl must be at the very end of the molecule if it needs to have a hydrogen here. If you add a carbon here, then what happens? So let's take an example of that. So if I draw a molecule here, and then I have a carbonyl, but then there are more carbons, okay? So you see this carbon right here, which is sitting here, this carbon has a bond with a carbon on the left, carbon on the right, so that's 2 bonds already, and then 2 bonds with the oxygen. So carbon is now full it's not full with all 4 bonds, right? So this carbon does not have a hydrogen. So you see these 2 molecules are different. This is C double bond O carbonyl, sitting at the very end or sitting at the edge of the molecule. That's when you have an aldehyde, okay? But when the carbonyl is somewhere sandwiched between the carbon chains, then you have what we call ketones, okay? So if I want to draw a ketone here, like the general structure of ketone, then this is what it will look like. So you will have a carbonyl not at the edge, because you have carbon chains on the left and carbon chains on the right, okay? That's when you have a ketone. But for an aldehyde, you have a carbonyl, C double bond O. It has a carbon on one side, but then it has hydrogen on the other side. And of course, whenever you have hydrogen, that means that's the end of the molecule. There's going to be no more carbons here, right? So that's when you have aldehyde. So aldehyde is carbonyl sitting at the edge, okay? Whereas ketones, they have C double bond O carbonyl sandwich somewhere in between. And guys, because of the presence or absence of this hydrogen, so this hydrogen which is present in aldehyde and not present in ketone makes a lot of difference in their chemical and physical properties, okay? All right, so let's keep going. The next category of functional groups that we want to discuss, they're called carboxylic acids. Okay, so guys, carboxylic acids, as the name suggests, they're acidic in nature. And guys, remember, whenever something is acidic in nature, we mean that acids, they lose proton, they lose H+. H+ is also called proton. So any molecule which is able to lose H+, we call them acidic, we call them acids. So carboxylic acid, think of, this is the acidic version in organic chemistry, okay? So if I have, you know, again, a carbon chain, but that carbon chain, if it has a C double bond O, again, do you see that carbonyl coming in again? We saw the C double bond O earlier in aldehydes and ketones. We are seeing them again. But this time, this carbonyl is actually attached to one more oxygen, and this oxygen is bonded to hydrogen. Okay, so you have to pay attention here. This is, let me draw this again, because you will see carboxylic acid drawn differently everywhere. So you must understand that they are actually the same thing. So guys, when I have this carbonyl functional group, when this carbonyl is sitting next to the OH, that's when you have the carboxylic acid. And guys, remember we said the word acidic, it is because that they can lose this H+. So this hydrogen leaves without the electron and oxygen keeps its electron. So this molecule can change into this. So it keeps the electron, so it gets a negative charge, and this H plus gets separated. So this is carboxylic acid who donates the H plus to somebody else in the solution or in the reaction. Okay, and then this molecule that you make, you call this carboxylate. Okay, and this here is the proton. So what we need to understand from here is that carboxylic acid has this C double bond OOH. Okay, and you will notice one more thing, that carboxylic acid also, if there's another way to show it, is if I draw, let's say again, carbon, and then sometimes what you will see is that the COOH is not shown explicitly like it's shown here, but it's just written like this, COOH. Or even you can condense it further, and sometimes you will see it written like this. So instead of writing O twice, you will write O2 and then H. So guys, again, all of these are very common ways to show carboxylic acid, COOH, CO2H, or actually drawing it like this, or writing OH like this condensed without showing that bond. Okay, so all three four are common ways to show carboxylic acid, and you must be able to identify each of these individually. Okay, now let's go further, and you will notice we go to next functional group. And guys, the best way to actually remember these functional groups is to compare and contrast. When you will notice the differences between these molecules, between these functional groups, that's when you will be able to identify them easily. Okay, now the next functional groups that we want to talk about are esters. Esters, guys, these are what give different fruits their fragrances. So guys, ester, again, very important organic molecules. So think about this. Think of oranges or apples, pear, banana, how they have, or pineapple, how they have different fragrances, and you can actually identify them. So your nose basically have the senses to actually identify one ester molecule different from the other. So basically different flavors, they're made up of different type of ester molecules, and our nose and brain have the capability to recognize the difference between those ester molecules. Okay, so now let's take a look of what ester molecule actually looks like. So guys, you will see carbon. Again, guys, when I'm drawing 2 carbons, or if I'm not drawing any, if I'm drawing 5 carbons here, that does not make any difference, guys. It is the functional group this is the actual business end. Okay, so the general formula for carboxylic acid is just this. This is what matters. Okay, now coming back to the ester, let me just draw the regular common general structure first. So guys, what happens here is you have a carbon chain, then you again have that carbonyl. So this is the 4th time we're seeing carbonyl. We saw carbonyl in aldehyde, then we saw it in ketone, then we saw it in carboxylic acid. Now we're seeing it ester. So now in ester, what is the difference? Yes, we have this carbonyl, we have the C double bond O, but this is connected to oxygen. We have seen that before as well. We have seen that in carboxylic acid. In carboxylic acid, we had the same thing. We had C double bond O and O, C double bond O and O. But then in the case of carboxylic acid, you had this hydrogen. Instead of that hydrogen, if you remove that hydrogen and actually add more carbon chains, let's just call that R prime. When you add more carbon chains on the right-hand side here, instead of the hydrogen, you make ester. Okay, so if I try to show you an actual example, so guys, there will be a carbon chain, there will be a C double bond O, there will be another oxygen, and then there will be another chain. So it's like showing you have carbon, then you have the C double bond O, then you have more carbons here, but the attachment is via oxygen. Okay, so you have carbon, but then you have this C double bond O and O, this part here, which is sandwiched between the carbon chains. That's when you make an ester. Okay, I hope that is making sense, and you guys are able to differentiate ester from carboxylic acid. Carboxylic acid, remember, they're acidic. They must have the H plus. I mean, they must have the hydrogen to lose, so they have this hydrogen. Esters, they don't have that hydrogen here anymore, and that's why esters are not acidic, because they don't have that hydrogen, okay? All right, so let's keep going further. The next functional group we want to talk about is amine, and we will do the last one, amide. We'll do them together, okay? So now, whenever you see the word AM in chemistry, so for example, ammonia, ammonium, amine, amide, understand that we are talking about nitrogen. Okay, so guys, if I have a carbon chain and that carbon chain is bonded to nitrogen, you have what we call amine. Okay, keep in mind, nitrogen can make 3 bonds. Okay, I'm just putting X here to show you that there's something attached on the nitrogen. So nitrogen can make 3 bonds. If nitrogen is making 1 bond with a carbon chain on the left-hand side, I mean, the side does not matter, but the nitrogen, if it's making a bond with a carbon chain, then the other 2 are hydrogens. Okay, there could be, these hydrogens could be replaced by more carbons, but still you have what we call amine. Okay, so if I give you an actual example, you have a structure like this, and at the end you see NH2. Or if I show you a structure like this, there's a nitrogen and there is more chains and there's still 1 hydrogen here. Okay, or I replace all the hydrogens and I make a structure like this. So you see, this is nitrogen with a carbon on this side and then 2 hydrogens, so still 3 bonds. This nitrogen, same thing, carbon on the left, carbon on the right, and then hydrogen, still 3 bonds. This nitrogen also, carbon on the left, right, and top, still 3 bonds. All of these are amines, okay? And this one is a primary amine, this one is secondary, and this one is tertiary amine. Okay, the idea is that whenever you have nitrogen connected to a carbon chain, we have what we call amine. Okay, now what happens when you have an amide? Now, amide, guys, the difference is that carbonyl comes back, and that's when you have the nitrogen connection. So the nitrogen connection is not directly with the plain carbon chain, but nitrogen connection is with the help of a carbonyl, and then there's just plain carbon chains. Okay, so this is when you have an amide. So an example for this, guys, will be something like this, something that will have, again, a C double bond O, and then you have a nitrogen. So whenever you see this, that's when you have an amide. Okay, again, very different functional properties between amine and amide because of the C double bond O. This is actually a very important molecule. This connection is what you find between the protein. So when a protein is, we will learn this later on in the semester, when we make protein molecules, they are actually connected amino acids, and amino acids are nothing but protein is nothing but amino acids joined to each other with the help of amide bond. Okay, we'll learn that more later on, but for right now, just understand how to identify these functional groups. Okay, so now let me give you some examples, some more examples, and you guys try to identify the functional groups here. Okay, so yeah, actually one more thing before I head on. So guys, there's this molecule that I wanted to make sure you guys have seen before or understand if you see it. So guys, this molecule, this you see, it looks like cyclohexane, so 6 carbons in a cyclic chain. If I have a double bond on it, not just 1, not just 2, but if I have 3 alternating double bond on a cyclohexane, then what you make is a special molecule called benzene, a very important organic molecule, a typical organic molecule, very non-polar. This guy is called benzene. Okay, so you should be able to identify this by itself. It is not understood as a functional group. It is actually the main parent chain. But this benzene, when you see it, it might have some attachments on it. And if you see attachments on it, you should be able to identify them. So can you identify, guys? You can pause the video here for a second and try to identify what functional group do you think this is? So guys, where have we seen this COOH before? This COOH, this is nothing but carboxylic acid. Okay, because you're saying C double bond OH, carboxylic acid. Okay, or this molecule could have been shown like this, and that will not make any difference if I show it like this. This is still carboxylic acid. You want to make sure you understand this part, okay? All right, so if we draw, let's say, another molecule which has this, what will this be called, guys? You got NH2, plain NH2, no C double bond O. This guy is called amine. Okay, so again, if I draw a molecule like this and I put an OH here, pause the video and try to identify what functional group do you think this is? Okay, so whenever you see OH, just like that, you call this alcohol. Okay, right. Let's do just a couple more examples. If I have a molecule which has something like this. So guys, here you have, let me draw this again, just in case that is confusing. So this, okay. So you see, I've got a C double bond O this time, so C double bond O. Is this C double bond O sitting at the very edge of the molecule, or is it sitting somewhere sandwiched in between? Guys, this is a carbon. What is this? This is also a carbon, and this is also a carbon. This guy here, pause the video and try to think what this is. So guys, C double bond O, when it's sandwiched between carbons, this guy is ketone, okay? And if I have to circle this, this part is ketone, okay? Now, if I draw a same molecule, but I end it here with a hydrogen. So guys, now the C double bond O, oops, let me draw this again. So this time, oops, not that. When I draw a line like that, guys, we are saying that there's a hydrogen. But if I actually want to put a hydrogen, then I should explicitly say it's hydrogen, okay? That's the difference here and here. Here, even if I don't draw the carbon, when I just draw an empty line like that, we assume that that's a carbon, right? Each starting point, end point, intersection point of these lines is a carbon. But here, when I say hydrogen, then I'm trying to say this is not a carbon, but a hydrogen, okay? So this, guys, try to guess what the answer is. So when you have the C double bond O sitting at the very edge, at the end, this guy is an aldehyde. Okay, so I hope, guys, that makes sense. If you have any questions, let me know, okay? That's it for this video.